artery circulation. Last year's video, hopefully you are not watching, but obviously not watching if you are watching this one, was very, very long in terms of all the different vessels. We're going to spend some time looking at the different types of vessels in class, but for this video we're only going to look at just the names of them, the structure, the function, and then where they're all actually located. Okay. So first of all, if you look at the different types of blood vessels that we have, most of them are pretty familiar to you guys. You know about arteries, you know about veins, and you probably have heard of capillaries. The only other ones that you might not heard of are arterioles and venules, and all they are is just that intermediate between arteries and capillaries, or between veins and capillaries. So here they are. So let's look at the function first. Excuse me. So we're going to look at the function, the structure, and the location of all three of these vessels. Really, we're just looking to compare and contrast. We talked about in class yesterday, all arteries carry blood away from the heart. It does not have anything to do with oxygenated or deoxygenated necessarily in terms of their definition. The definition is that they carry away. However, majority of the blood in the body, in the arteries, are going to be oxygenated. And then it delivers deoxygenated blood to the lungs through that pulmonary artery that we looked at in class yesterday. Sorry, that probably went too fast. I might have to go back. So let's look at the structure. The thing about arteries is they're thick-walled, as you can see in this picture here. They're also elastic, and the reason why they're thick and elastic is that the artery walls are able to expand. There's a lot of pressure because they're being pumped. That blood is being pumped away from the heart, and so it's increase in pressure, so it needs to have an infrastructure in terms of being elastic and thick-walled. And the other thing is that after it flexes and pulses, it stretches and then they rebound after each contraction, so it goes back to the original size. Okay, so let's look at the location. It makes sense if you think about location once you hear it, is that they're deep in the tissue along the bones. Because what you want, since these are highly pressurized vessels, we want them to be away from any place where injury can result. So if they're near the top of your skin, how many times do people cut themselves just superficially? And we don't want that to be hitting an artery. And like you guys have seen in the movies where someone gets an artery cut, it's pretty much just squirting out because of that pressure. And there's tons of blood that's lost in a low amount of times because of this pressurization. So veins, as we talked about last day, is that they carry blood back to the heart. The vast majority of them are going to be carrying deoxygenated blood, except for the lungs that carry oxygenated blood back from the lungs to the heart to be pumped to the rest of the body. Sorry if that went too fast. The veins, in terms of their structure, completely different than arteries in terms of their size. These ones are thin-walled because they're not pressurized. They don't really receive a lot of blood, so there's no need for that elastic walls. So low pressure. But what they do have are these things called valves. Just like you had in your heart, the valves are meant to prevent blood flow because these aren't being pumped. Veins that carry blood back to the heart need muscle activity in order to actually push the blood back against gravity back up to the heart. Okay, so let's look at their location. These locations are closer to the surface and they're near skeletal muscle, which means like skeletal muscle. And the reason why is that that skeletal muscle pushes on the vein when it contracts, and it pushes that blood through those valves. And lower pressure, so less blood loss, if severed, so it can be near the surface where injury may result. Okay, arterioles and venules. All these are just small arteries and veins. They have the same features but just on the smaller scale, so in terms of their thickness and elasticity for arteries and their thin wall valve for venules. Arterioles also have a sphincter muscle, right? That circular muscle that we have in our stomachs. In order to dilate and contract, so get bigger or get smaller depending on the blood pressure and their flow. So if the blood pressure is too high, it can dilate to reduce that pressure. So blood temperature is regulated this way. If we want to have more blood flow to the surface because it's cold, that blood will go to the surface when those capillaries open up, or sorry, those arterioles open up, and it reduces the temperature loss. So pause that and write that down. Excuse me. And then to prevent temperature loss, blood is prevented from going to the, oh yeah, so also in this situation, have you ever seen where you get really cold or people with frostbite start to have really white tips? And it's because they want to prevent temperature loss from your main vital organs, your core, and so it prevents it from going to the tips, and that's why they can go white, because no blood's getting there. Okay, so let's finish off with capillaries. Capillaries are just the interconnected network here that are going to go to all of the cells, and it connects arteries to veins. So it delivers water, oxygen, nutrients to the tissue, and it picks up water and waste from extracellular fluid. So what you want to realize is that these capillaries is that it's going to run within a few cells width between one cell to the next. So there has to be capillaries around every cell, otherwise it won't be able to get its nutrients and those cells would die. So let's talk about the structure. Very thin walled. Why would it want to be very thin walled? Oops, sorry. And it's because it needs to diffuse nutrients and gases in and out of those cells rapidly. The location, everywhere. And they have, like I was saying, they have to be within a few cells of each other because you need to provide nutrients and gas exchange for all of those cells. So take a minute to copy those ones down. So these major blood vessels, we're not going to get into today's video. You guys will be able to see these on Monday when I return. So if you have any questions based on that, write them down. But it's pretty much just looking at those three vessels. So your arteries, capillaries, and veins, and making sure you know the structure, location, and function of those. Okay, have a wonderful night.